Touching down on the frozen surface of Pluto, the screen comes alive with the frosty shimmer of the icy terrain, giving viewers the sensation of the extreme cold. The chill of its thin atmosphere grips us, enhanced by the ethereal blue particles sweeping across the screen. It's a surreal experience as the frosty wonderland unfolds in the middle of a cosmic desert. The temperature here is dramatized by visual effects of crystallizing breaths and freezing equipment, all signifying the drop below 300 degrees. The air, thin and almost ephemeral, is depicted by the sparse, ghostly clouds, composed primarily of nitrogen with traces of methane and carbon monoxide. It's not something we could breathe, but it creates a visually stunning environment, unlike anything we've encountered before. And then there's the sun. From our vantage point on Pluto, the sun is portrayed as a faint, distant star, its light barely penetrating the icy landscape, depicted by hues of blues and purples and the fleeting sparkle of sun rays. It's a hauntingly beautiful sight, a stark reminder of the vastness of our solar system, brought to life with visual effects of astral bodies across the screen. As we witness the distant sun, it is enhanced as a mere speck of light in the dark sky, flickering and pulsating in the cold void. Welcome to Pluto, an icy world of wonders waiting to be visually and vividly explored. The landscape here is unlike anything on Earth. Picture a world where the mountains are not made of rock, but of water ice as hard as granite. These towering peaks rise dramatically against Pluto's thin atmosphere, creating a surreal and breathtaking panorama. The plains are not made of soil or grass, but of nitrogen that has frozen solid. These nitrogen glaciers creep slowly across the surface, a dance that takes centuries to perform. This is a place of extremes, where the familiar becomes alien and the alien becomes familiar. As we traverse this icy terrain, we encounter massive chasms and dark valleys, evidence of the geologic activity that shapes this distant world. The stark beauty of Pluto's landscape is a testament to the diversity of our solar system, a reminder that each celestial body, no matter how small or distant, has its own unique story to tell. Let's take a moment to appreciate the stark beauty of this alien world. Despite its thin atmosphere, Pluto's skies are not devoid of activity. Even though its atmosphere is over 100,000 times less dense than Earth's, it is a constant scene of spectacular phenomena. The thin layer of nitrogen, methane, and carbon monoxide gases that make up Pluto's atmosphere interact with the sunlight to create an ethereal glow. This faint luminescence, though not as grand as our northern lights, is a spectacle of its own. The sun's rays, though far weaker than what we experience on Earth, still have enough energy to excite these gases. This energy causes the gases to emit light, creating a sort of atmospheric glow. This glow is not constant, though. As Pluto orbits the sun in its elongated and tilted path, the intensity of the sun's rays changes. This causes the glow to wax and wane, providing a unique and ever-changing light show. We observe the faint glow of atmospheric phenomena created by the interaction of sunlight with the planet's unique composition. Scientists believe Pluto holds clues to the early solar system. Its icy surface, scarred by eons of cosmic impacts, has a story to tell, and we're here to listen. As we journey to the heart-shaped Tombaugh Regio, we delve into the history of this distant dwarf planet. This region, named in honor of Clyde Tombaugh, the astronomer who first discovered Pluto, is a treasure trove of geological wonders. Here, we find signs of ancient impacts, hinting at a time when our solar system was a violent place filled with colliding celestial bodies. But there's more to Tombaugh Regio than just its impact history. Scientists speculate about the existence of a subsurface ocean hidden beneath the icy crust. Could this ocean hold the key to understanding Pluto's past and possibly its future? We visit the heart-shaped Tombaugh Regio, named after Pluto's discoverer, to explore the possibility of a subsurface ocean and the remnants of ancient impacts. While Pluto doesn't boast traditional life forms, we dare to dream and delve deeper into the realm of the unknown. we are here to explore the intriguing possibility of life beyond our comprehension. Could there be microbial life thriving beneath the icy surface of this distant dwarf planet? Pluto's subsurface oceans, hidden deep beneath its icy shell, could potentially harbor life. These oceans, believed to be composed of a mixture of water and antifreeze-like chemicals, are kept liquid by the heat generated from the radioactive decay of rocks and the gravitational interactions with its moon, Charon. Now, when we think about life, we often picture something familiar, something we can relate to. But life on Pluto, if it exists, would be unlike anything we've ever seen. The extreme conditions of this icy world, with temperatures plummeting to -375 degrees Fahrenheit, mean that any life form would need to be extraordinarily resilient. This is where we venture into the realm of speculation and imagination. What could these potential life forms look like? Are they similar to the extremophiles we find in Earth's most inhospitable environments, microorganisms that thrive in conditions lethal to most life forms? Or are they something entirely different, organisms so alien that we can hardly conceive of their existence? These are the questions that keep astrobiologists up at night. And these are the questions that make the exploration of Pluto so exciting. The possibility of discovering life on Pluto, or any other celestial body for that matter, would revolutionize our understanding of life's diversity and resilience. So, while we haven't found any signs of life on Pluto yet, the potential for discovery is immense. Scientists speculate on the existence of exotic, unseen organisms adapting to the extreme conditions. Each new probe, each new mission, brings us one step closer to answering the age-old question: are we alone in the universe? Opening. A day on Pluto lasts about 6.4 Earth days. Now let's imagine, what would it be like to spend a day on this distant world? Given that a single day here lasts almost a week on Earth, it's certainly a unique experience. The sunlight filtered through the thin atmosphere casts a faint, ethereal glow over the icy landscape. The long day allows us to truly observe and appreciate the stunning wonders of this dwarf planet. As the day progresses, the sunlight interacts with the icy surface, creating a spectacular play of light and shadow over the nitrogen glaciers and ice mountains. It's a sight that's nothing short of poetic, a testament to the stark beauty of this alien world. Even as we witness this mesmerizing display, it's worth noting that timekeeping on Pluto is quite different from what we're used to. With its elongated day and tilted axis, the concept of morning, afternoon, or night doesn't quite apply on Pluto. Instead, the planet experiences a long, slow transition from light to dark and back again. The slow rotation of Pluto also means that certain regions of the planet can experience continuous daylight or darkness for extended periods. Imagine, if you will, a day that stretches on for what feels like an eternity, followed by a night that seems to last forever. It's a concept that's hard to grasp, yet it's the reality on this distant world. As the day on Pluto draws to a close, we witness the gradual set of the distant sun. The faint light slowly fades, swallowed by the immense darkness of space, leaving behind a landscape bathed in a soft, ethereal glow. Closing. From the gradual rise of the sun to its distant set, we've experienced a day on Pluto. Communication with Earth from Pluto poses unique challenges due to the vast distance. Imagine you're on Pluto and you're trying to send a message back home. Given Pluto's location at the edge of our solar system, that message has to travel about 3 billion miles. This is not a journey that happens in a flash. It's a slow trek, even at the speed of light, taking about 4.5 hours. So if you were to say, "Hello Earth" from Pluto, you'd have to wait 9 hours just to hear "hello" back. Now, this isn't a simple long-distance call. The technology involved in making this communication possible is quite intricate. We use what's known as the Deep Space Network, a worldwide system of large antennas and communication facilities operated by NASA. This network sends and receives radio waves, carrying data to and from distant space probes. But these signals are not strong. They're more like a whisper in the grand cacophony of the cosmos. In fact, the signal strength from a spacecraft at Pluto's distance is about 1 billion times weaker than that of a mobile phone signal. So to pick up these faint signals, we use massive dish antennas, some as large as 70 meters in diameter. Even with all this technology, communication is not always smooth. Solar storms, for instance, can disrupt the signal. Plus, the rotation and revolution of the Earth and Pluto can sometimes put them out of alignment, causing further communication delays. So, while it may seem like a mammoth task, with the right technology and a little bit of patience, we've managed to maintain a link with our probes on Pluto, helping us learn more about this fascinating dwarf planet. We delve into the technology behind maintaining contact with our home planet and the delays involved in exchanging information.